SwayamPrabha. Digital India. Educated India.
Dear students, you are welcome in this class. I am Dr. Dinesh Kumar, Principal Scientist from Division of Agronomy, ICR, Indian Agricultural Research Institute, New Delhi. And this course pertains to the title Agronomy of Oilseed, Fiber and Sugar Crops. And title of the lecture is Nutrient, Water, Weed, Insect Pest and Disease Management and Processing of Safflower Produce. The learning objectives of this lecture are nutrient, water and weed management practices in safflower crop, and then you will also learn about the insect pests and diseases management and processing of safflower produce. So some glossary, some difficult words. Bacteria, unicellular organism including free living, saprophytic and parasitic forms. Basin, an area of land that drains all the streams and rainfall to a common outlet such as the outflow of a reservoir or any point along a stream channel, or this you can also call as a watershed. A chemical that causes the leaves to abscess from a plant is called as defoliant. Ecological amplitude, the range of environmental conditions in which an organism can survive, are ecological amplitude. Emulsifying agent, a surface active material that facilitates the suspension of one liquid into another. Endangered species, any plant or animal which is danger of extinction throughout all or a significant portion of its range. Inflorescence, several flowers closely grouped together to form an efficient structured unit called inflorescence. Integrated pest management, it combines the use of prevention, avoidance, monitoring and suppression strategies in a way that minimizes economic, health and environmental risks of pest attack on crop. Leaching, the process where material in the soil, maybe nutrients or pesticides, are washed away into lower layers of soil by the downward movement of water. Leaching. So, leaching happens in case of certain nutrients, particularly those who have negative charge, or anions like sulfate can be leached down, nitrate can be leached down and so on. Luxury consumption, the absorption by plants of an essential nutrient in excess of the need for growth, and this is mostly observed in case of potassium. Now we go to the nutrient management. So nutrient management is very important cultural practices in the cultivation of safflower. So in this case we need to decide the optimum source for supplying different nutrients and what should be the right time of supplying the nutrient and what method should be followed to supply the nutrient. All these subjects are part of nutrient management practices. In general, it is advisable to go for integrated nutrient management practices where all the sources which are available to supply nutrients are combined together to supply different nutrients. And it is also advisable to go for balanced fertilization. The nutrients should be supplied in right proportion to the crops. So now we will discuss this nutrient management under different headings. You can say nitrogen management, followed by phosphorus, potassium, secondary and micronutrients management, and then we will discuss the time and method of fertilizer application, and finally we will discuss the integrated nutrient management. Let us start with nitrogen management. It is very important nutrient in production of safflower, and as many of you know that deficiency symptoms of nitrogen come on lower leaves because it is mobile in the plant system and it quickly moves to the younger parts or young leaves or young shoot region, and the deficiency is experienced in the older part or lower leaves. and it can be easily translocated from older parts or older leaves to the new parts. And the deficiency is uniform chlorosis. Chlorosis can continue in this case. So more than 50% nitrogen uptake takes place between the first bloom and maturity. Nitrogen affects not only the yield, the total yield of seed, but also affect the seed composition, particularly concentration of oil in the seed. Nitrogen increases seed yield primarily through its effect on number of heads per plant and the increase in greatest tertiary and to a later extent in secondary heads. So overall main effect of nitrogen in safflower crop is to increase the number of heads or number of flowers per plant. That is why it is capable of increasing the seed yield of safflower crop. The level of nitrogen application depends on native soil fertility, soil moisture status, preceding crop and yield potential of the cultivar. That means if your native fertility is high, then you are required to add nutrient less. Similarly, soil moisture status, if you have lower supply of moisture, then you have to supply lower doses of the fertilizer or nutrients. And also the yield potential of the cultivar is important. If you have high-yielding cultivars or hybrids, then the nutrient requirement will be high compared to the varieties. At number of locations in India, economic response to nitrogen application was observed even beyond 60 kg nitrogen per hectare. In double cropped areas, recommended dose of nitrogen can be reduced by 50%, amounting to 20 to 25 kg nitrogen per hectare if preceding crop is grain legume. So this is always a better idea to start the crop rotation with a leguminous crop, because they fix atmospheric nitrogen into the soil and which can be made available to the succeeding crop. So therefore, in this case, if a preceding crop is legume before taking safflower crop, so it can save about 20 to 25 kg nitrogen per hectare. Under irrigated conditions, only 50% nitrogen must be applied at the time of seeding and the rest must be top dressed 5 weeks after later at the time of first irrigation. So in this case, nitrogen should be applied twice in this case. By applying 2 times or 2 splits of nitrogen, we increase the nitrogen use efficiency. Otherwise, if we apply only basally this nitrogen use efficiency will be less because losses of nitrogen will be more. Soil moisture affects the availability of crop nutrients, and when nitrogen is applied to irrigated safflower, there can be an interaction between the total amount of water and nitrogen supplied. So as we know, safflower can be grown under 2 conditions. One is rain-fed, other is irrigated. In rain-fed conditions, it needs lesser nutrient because there is no water, there is no sufficient water. Water stress is there. Under this condition, the nutrients cannot be mobilized towards the plant root and uptake can be affected. However, if there is adequate supply of water or moisture in the soil, any amount applied to the soil can be easily transported to the plant root and can be efficiently utilized by the plant. So therefore, it can be understood clearly that under rain-fed conditions, the requirement of nitrogen and other nutrients is less compared to the irrigated conditions. Now coming to the phosphorus management, let us understand the deficiency symptoms. The deficiency of phosphorus come like nitrogen on the lower leaves and it is not coming on the younger parts or young leaves. So what happens, the leaf can become darker green with some purple discoloration. Some purple pigments are accumulated on the lower leaves. So that is typical deficiency symptom of phosphorus. So safflower responds well to adequate phosphorus in the seedling stage, and small amounts band placement at planting time promote rapid initial growth of the seedling stage and improve general plant health. So in this case, phosphorus, if we are applying water soluble phosphorus through single superphosphate or DAP, then it must be band placed near to the seed or just side placement can be adopted. Safflower is deep-rooted crop and can draw on a considerable volume of soil for nutrients. Its added phosphorus requirement in particular area may thus be substantially lesser than for more shallow-rooted crops. Response to applied phosphorus was reported from a number of locations in India. About 25 to 40 kg P2O5 per hectare is optimum. Phosphorus application has increased the number of productive capitula and the number of seeds per head. So, it is in the line of nitrogen's effect that it also increases the head number as well as seed number. For maximum effectiveness, phosphorus must be band placed before sowing of the safflower. So, whatever recommended dose of phosphorus is there, that should be applied basally or as particularly as a band placement beside the seed. The greatest effect of phosphorus occurs when combined N and K, nitrogen and potassium, when it is also increase the P content of seed but not of straw. So, overall you can see we need to apply nitrogen, phosphorus, potash adequately but in right proportion. However, it is always advisable to apply phosphorus based on soil test value, as very high soil phosphorus status can adversely affect the zinc availability. So, if the proportion of phosphorus and zinc is not right, then they can affect each other's availability. If phosphorus is in excess, it will depress the availability of the zinc, and if zinc is in excess, it will depress the availability of the phosphorus. It can also be benefit from residue of large application of phosphorus to previous crops. Now, after nitrogen and phosphorus, let us see potassium management in safflower crop. Application of potassic fertilizer to safflower is usually unnecessary except in those areas where a serious deficiency of this nutrient exists. In general, application of potassium to the preceding crop has been found sufficient for following crop of a safflower. However, due to extensive cropping and due to soil erosion and some other losses, potassium may be medium or low in certain soils. Under those conditions, we may require application of potassium based upon the soil test basis. So, now we go to the secondary and micronutrient management. As you know, calcium, magnesium and sulfur are considered as secondary nutrients, and there are 8 micronutrients which includes zinc, boron, iron, manganese, molybdenum and so on. So, studies under All India Coordinated Research Project on safflower have indicated a good response to the safflower to sulfur application in many areas. It is not just safflower. Many other oil seeds respond well to the sulfur application also, because these days we are experiencing deficiency of sulfur in several soils in several regions. Application of 30 kg sulfur per hectare through single superphosphate or elemental sulfur before planting has been found to be quite economical. However, the gypsum is also a good source to supply sulfur. So, gypsum can also be used in place of elemental sulfur. If we are using elemental sulfur as a source of sulfur, then it should be applied at least 1 month before sowing of the crop. If phosphorus is supplied through single superphosphate, sulfur requirement of the crop is taken care of adequately. There is no need to apply extra sulfur from outside if we are using single superphosphate fertilizer, because it contains sufficient quantity of sulfur. There have been no reports of deficiency of trace elements affecting safflower yield in the field. However, some reports indicating significant responses to the zinc application. So, many times soil tests, if they suggest the deficiency of zinc, then it should be applied through fertilizers. Particularly, zinc sulfate heptahydrate can be used to supply zinc under deficient conditions. Now, coming to the time and method of fertilizer application in safflower, response to applied fertilizer depends on the method and time of fertilizer application. This is very important. Under rain-fed condition, it is better to apply a full quantity of fertilizer as basal by drilling. Under rain-fed condition, whether it is phosphorus, potassium or nitrogen, all fertilizer should be applied basally, and it is better to apply by drill method than broadcast application. The efficiency of fertilizer use is less if we apply it through broadcast method. it is always to go for placement, particularly phosphatic and potassic fertilizer should be placed in band so that they come in minimum contact of the soil. So that way we can reduce fixation, particularly fixation of phosphorus can be minimized. Fertilizer should be placed in deep furrows about 10 centimeter below the soil, and seed must be sown adjacent to the fertilized rows. In monocropped areas of Maharashtra and Karnataka, application of fertilizer 2 to 3 weeks prior to optimum planting time was found best for increasing the fertilizer use efficiency under receding soil moisture. Under irrigated conditions, it is advisable to apply phosphorus and potassium and 50% of nitrogen at the time of seeding, and the rest nitrogen must be top dressed 5 weeks later at the time of first irrigation. So overall you can see you have to place phosphatic and potassic fertilizer as basally, and also 50% nitrogen should be applied basally, and remaining 50% nitrogen should be top dressed after 5 weeks of crop at first irrigation. Now we go to the integrated nutrient management, where all the possible sources of nutrients like organic fertilizers and biofertilizers are combined together to supply the nutrients. So there are some reports of the beneficial effects of seed inoculation with Azotobacter, Azospilum, and application of AM fungi. AM fungi is very important, arbuscular mycorrhiza fungi. These are considered as biofertilizer, and they solubilize the phosphorus, particularly phosphorus in the soil, because we know phosphorus is mostly in the unavailable form in the soil. So these can solubilize or mobilize phosphorus to the plant roots, and uptake of phosphorus is increased by AM fungi. And besides phosphorus, AM fungi are also known to increase the uptake of other nutrients also, particularly zinc. So combined use of farmyard manure 6 ton per hectare and 20 kg nitrogen per hectare gave 42% higher yield than the use of 40 kg nitrogen alone at Indore. So you can see the integration of manure or organic manure and fertilizer is beneficial. This also increased the water use efficiency and helped in alleviating the harmful effect of drought and frost, because these organic materials are known to improve the soil structure, and this improved soil structure results in improved water holding capacity of the soil. So therefore, crops where organic manures are supplied can better withstand the drought conditions. Integrated use of organic and inorganic sources, or you can say fertilizer, has proved vastly superior to the use of one of them in safflower. Means either you use fertilizer alone or you use manure alone. They are not beneficial, they are not as much effective in increasing the yield as their integrated use. Recommended levels of manures and fertilizers for safflower are given in next slides. So now you can see recommendations for Andhra Pradesh and Telangana, and you see different columns like farmyard manure, fertilizers, and P2O5 and K2O kg per hectare. So this is integration of farmyard manure and fertilizer sources. So for Andhra Pradesh and Telangana, you can see under rain-fed condition, there is no recommendation of FYM, but you can use 40 kg nitrogen and 25 kg P2O5 per hectare, and this quantity should be added at the time of sowing in the soil. Similarly, for Gujarat, no recommendation of FYM and K2O, but you need to use 25 kg nitrogen and 10 kg P2O5 per hectare in Gujarat. For Karnataka, rain-fed condition, 6 ton per hectare FYM, 35 nitrogen, 50 P2O5 and 25 kg K2O per hectare is recommended. And for irrigated areas, you see nitrogen is increased, phosphorus is increased, and potassium is also increased. So for irrigated conditions, 6 tons per hectare FIM, 75 N, 75 P2O5 and 35 K2O kg per hectare is suggested. For Madhya Pradesh and rain-fed condition, 40-40-20. For irrigated conditions of Madhya Pradesh, 60-40-20 kg N P2O5 and K2O per hectare. For Chhattisgarh, rain-fed 30-20-15. For irrigated condition of Chhattisgarh, 60-30-20. So these are the recommendations for these states. Now coming to Marathwada region, rain-fed 40-20 N and P2O5, no FYM, no K2O. For irrigated condition, fertilizer quantity is more. For Marathwada, 60 kg nitrogen and 40 kg P2O5 per hectare. For Vidarbha region, rain-fed, here 5 to 10 tons per hectare FYM, 25 kg nitrogen and 25 kg P2O5. For irrigated region of soils of Vidarbha, 5 to 10 tons FYM, 50 kg nitrogen per hectare and 50 kg P2O5 per hectare are the recommendations. Odisha, for rain-fed conditions, 6 ton farmyard manure per hectare, 25 nitrogen, 25 P2O5 kg per hectare. Coming to all other areas of the country, for rain-fed regions, 40-20 N and P2O5, and for irrigated condition, 60 and 40 kg nitrogen and P2O5 kg per hectare respectively. So these are general recommendations of fertilizer and manures for different parts of the country. Now after nutrient management, let us discuss the water management. As many of you could understand very well that safflower is mainly grown as a rain-fed crop, but it has also been found that irrigation, supplemental irrigation can also lead to increased growth and improved yield of this crop. So of course, safflower is tolerant to water shortage or water stress at the rosette stage. This rosette stage is actually vegetative stage, and drought conditions at this time do not appear to have any major effect on subsequent growth and yield. However, water shortage during the normal period of maximum growth from rosette until flowering causes a marked reduction in growth and delayed maturity. So during this particular period, there should not be shortage of moisture in the soil. Moisture stress during flowering and maturation reduces yield and oil content and fast tense maturity. Fast tense means fast tense, it brings early maturity. In black soils, cracks begin to appear from December onwards with rapid loss of subsoil moisture. Cracks should be filled superficially with dust mulch as and when they appear to minimize moisture loss. So it is a good strategy to go for dust mulch. You can do shallow hoeing by khurpi or spade or any simple implement, and what happens, the capillaries are broken down, and in place of them they are clogged, and there will be less evaporation losses. In India, although safflower is raised mainly as a rain-fed crop, the crop responds well to application of water through irrigation. The seasonal consumptive use of the crop seldom exceed 250 to 300 millimeter. So consumptive use mainly includes your evaporation losses of the water plus transpiration losses of water plus water used in metabolic activity, which is generally very less, maybe 1% of the total consumptive use of water. Under scanty moisture conditions in dry land particularly, yield can be boosted or increased by 40 to 60% with just one life-saving irrigation, only 5 to 8 centimeter depth at the critical phase of the crop growth. When raised as an irrigated crop, safflower can give almost double the yield obtained from a rain-fed crop. So water has very important role in increasing the yield of this crop. Depending on the soil moisture status, give one irrigation at 35 days after planting in the early elongation stage, and another irrigation, means second irrigation, should be given at 65 to 70 days after days during the flowering period. 65 to 70 days during the flowering period. In light soils, about 5 to 6 irrigations are needed, including pre-planting irrigation amounting to 300 to 400 millimeter water. For efficient irrigation, following precautions may be followed. So this way we can increase the water productivity or water use efficiency. In soils that crack, particularly black cotton soils, apply irrigation well before the cracks develop or control of for control of water. So in this case, the better water management would be that farmers should not allow cracks to develop in the soil, and water or irrigation can be given just before the cracks are about to start. So do not delay irrigation till crop suffers from moisture stress, as it disposes to weeds and root rots. So irrigation should be given at right time. If there is provision for one irrigation, apply it before soil moisture becomes very critical for the crop growth. Now we go to the next subject, which is weed management. As many of the students know very clearly what kind of harms or losses are made by weeds to the crop. So is the case of safflower, where weeds can compete for nutrients, for water, for space, and for many other resources with the crop plant. And during this competition, they reduce the growth and yield of the associated crop. So ensuring weed-free conditions is critical so that the limited conserved moisture and fertility is not lost by the weeds. So good seedbed preparation and tillage are important. Safflower is highly susceptible to weed competition. During its rosette stage, which lasts for about 25 to 30 days in peninsular India and 50 to 60 days or more in other parts of prolonged winter. So these are very critical periods for weeds. So we should try to keep our crop weed free during these periods. That is, in some parts 25 to 30 days, and in other parts it could be 50 to 60 days or little more. Weed flora in safflower after Kharif rise is different from weed flora in other safflower based cropping systems. So fallow safflower, mung bean safflower or soybean safflower. Medicago denticulata is the most dominant weed. Chenopodium album and Cyprus aurea are also prominent weeds in this crop. Now you can have some identification of the weeds in this crop. So first one is lamb's quarter. It is Chenopodium album L, belonging to family Chenopodiaceae. See the next picture in the middle is scarlet pimpernel. Its scientific name is Anagallis r. vensis. In Hindi it is called as Krishna Neel, belonging to family Primulaceae. Then comes the sweet clover, and you can see yellow flowers are there. This is Melilotus indica, and it belongs to family Fabaceae or Leguminosae. And one more species is there which is called as Melilotus alba. That is very similar to this Melilotus indica in growth, but only difference is that Melilotus alba has white color flower and indica has yellow color flowers. Now see next weed which is fine leaf fumitory, and the scientific name is Fumaria parviflora. And then you see corn spurry, the scientific name is Aspergilla arvensis. Then onion weed Asphodilus tenuifolius. Then you can see on the bottom left the dark pink color flowers. It is Vicia sativa, which is called as common vetch. Then in the center you see wild safflower, Carthamus oxycantha. And then asthma herb, which is Euphorbia hirta, belonging to family Euphorbiaceae, this particular picture. Next you can see Euphorbia geniculata, which is wild poinsettia, this one. Second, camel thorn, Alhagi mororum. And then you see field bindweed. This is called as Hirankhuri also. Convolvulus arvensis L, belonging to family Convolvulaceae. So this has typical white color flowers, or sometimes it also has pink color flowers. Then you see bluegrass, which is Poa annua, canary grass Felis minor, Bermuda grass Cynodon dactylon. Annual beard grass, annual rabbit's foot grass, Polypogon monosplensis, this one. And then Cyprus rotundus, belonging to family Cyperaceae, and flat sage, which is Cyprus aurea, belonging to family Cyperaceae. Timely weeding and intercultural operations during this period are crucial for arresting the weed growth. It is necessary to give 1 to 2 hand weeding and hoeings and 25 to 30 days and 45 to 50 days. Means if you are going for just cultural control or mechanical control, then 2 hand weeding by suitable implement are enough. One can be done at 25 to 30 days after sowing and other can be done at 45 to 50 days after sowing. So 1 or 2 efficient post-emergence weedings are often sufficient, and additional cultivations while reducing the weed population do not significantly increase yield. So after that critical period, you need not to go for any operations. 2 to 3 hoeings up to flowering keeps the field weed free. It is popularly referred to as dust mulch and does that dual role of weed control as well as soil moisture conservation. Pre-emergence application of Alachlor at the rate of 1.5 or trifluralin at the rate of 1 kg AI per hectare is effective in controlling weeds in safflower. You can also use this fluchloralin at the rate of 1.5 kg per hectare, and diuran can also be used at the rate of 0.85 kg AI per hectare. And also you can use oxadiazone. Here you can see here oxadiazone 1 kg per hectare or pre-plant incorporation of fluchloralin or trifluralin at the rate of 1 kg AI per hectare. So number of herbicides are available, particularly pre-emergence or pre-plant incorporated herbicides. And these herbicides can be combined with cultural operations. And pre-emergence herbicide like oxyfluorophane can also be used. And we should ensure sufficient soil moisture while we are using soil applied herbicides. Now let us see the management of insect pests in safflower crop. So you can see safflower aphid, curling and yellowing of tender leaves. This is typical symptom of the aphid, and what happens, the adults and nymph of this aphid suck the sap from different plant parts, and they also secrete the honeydew like secretion on the upper surface of the leaf and plant parts, forming a black sooty mold which hinders photosynthetic activity, resulting in stunted growth, and finally the plant dries up. So these aphids are affecting plant mainly in 2 ways. One is that they are feeding on the plant, they are sucking the sap from the plant parts, and secondly their honeydew. They leave their honeydew on the leaf surface, and on which some black molds they grow, and then the photosynthesis area is reduced. Then we see capsule borer, Helicoverpa armigera, also called as gram pot borer. You can see its picture on the right side. In early stage, larvae feed on leaves and shoot apices. Later, larvae shift to developing capitula. Capitula is inflorescence. Perforated leaves, perforated partially or completely eaten capitula in the bud stage, and bored developing capitula. So you can see it is doing, or it is making bores in the capitulum of this particular crop. So far control is concerned, we will discuss their control together. Next is capsule fly, also called as safflower bud fly. Newly hatched larvae, the damaging stage of capsule fly is larvae stage, which are actually maggots. Maggots, they do not have any legs, feed on soft parts of the capsules. You can see damage being done on the right side to the capsules of this crop, and this is the fly, adult fly. You can see picture on the right side. So affected buds show small bore holes. So you can clearly see the holes in this picture. Holes are made here. Buds rotten with a foul smelling ooze coming out of apices or apex. Safflower caterpillar, the larva feeds on the leaves and sometimes on capitulum also. It also feeds on bracts, flowers and capsules. So this is the picture, greenish kind of caterpillar is there, and you can see it is devouring the leaves. Next is your cutworm. Cutworms are larvae of certain species of moss belonging to Noctidae. Noctidae family means their moth or their adult come out of soil during night time. They are active more during the night time. feed on stems of seedlings, and they can sever or chew through stems new ground level, causing plants to wilt, droop or die. So you can see brownish kind of caterpillar on the right side in the picture. Next important insect of safflower is safflower weevil. So weevils attack developing seeds. Adult weevils puncture immature seeds. They can make punctures or holes in the immature seeds and lay eggs inside. The hatched larvae then feed on seeds, causing damage that can lead to the reduced seed quality and finally the yield. So overall you have seen there are number of insects, say 5 to 6, and there can be many more also, and they are doing lot of damage. Some are eating the foliage part and some are making damage to the flowers or florets or to the reproductive part, and some are doing damage to the seed. So overall these will result in the loss of the yield. Therefore we need to control or we need to manage these insect pests, and as has been suggested by many scientists that integrated pest management is the best strategy to control the insect pests. So let us discuss the insect pest management in case of safflower. The crop should be planted as per the recommended planting time. Means it should be planted at optimum time of sowing recommended for a particular region, and delayed plantings suffer from damage from aphids. So if you delay the planting, you will get more infestation of aphids to your crop. In areas with high incidence of capsule borer, avoid intercropping safflower and chickpea. The caterpillars must be hand-picked and destroyed wherever possible. So it is also possible to hand-pick the caterpillar and take them out from the field and destroy them. In case of a high incidence of safflower fly, the infested flowers may be collected and destroyed, and light trapping may be followed for control. So what can be done? Spray the insecticide like thiamethoxam 25 Wg, and the concentration is 0.005%, or rate you can see 125 gram per hectare can be used, or imidacloprid can be used, which is 17.8% concentration, and it can be used at the rate of 0.0045%, or you can say 125 ml imidacloprid per hectare twice at 15 days interval. So number of insecticides are available. You can choose any one of these and use. The first spray may be taken up when moderate aphid infestation is noticed on the crop. Use 500 liter per hectare of spray fluid using a knapsack sprayer. Foliar spray of clothianidin can also be done, which comes in 50 WDG, and it can be used at 50 gram per hectare, or a combination insecticide. One can use chlorpyrifos plus cypermethrin 55 AC at the rate of 1 liter per hectare wherever aphid infestation was moderate. Means there is long list of insecticide that can be used to control aphid. Conventional insecticide like dimethoate can also be used, acephate can also be used, or dust quinol phos can also be used to control this insect pest. One can also use the neem seed kernel extract 5% spray at 40 days, followed by the spray of any of the chemicals mentioned above. Also gives effective control of most of the pests. So you can see the insecticide which are being used to control aphid will also control most of other insect too. So you need not to take several insecticides to control different insects. One insecticide which is of broad spectrum nature can take care of almost all the insects. Now after the insect pest management, let us see the disease and their management in safflower crop. The number one disease here is Alternaria blight, which is caused by Alternaria carthemi. So dark necrotic lesions which are 2 to 5 millimeter in diameter are formed first on hypocotyls and cotyledons. That means it can start coming to the plant or crop at the time of germination itself or field emergence itself. Is it mature? In mature plants, a small brown to dark brown concentric ring spores of 1 to 2 millimeter appear on leaves. So you can see on the right side in the picture, there are small brown to dark brown spots. Such kind of spots are there that you are clearly seeing, and initially or in the beginning they make concentric ring. You can see like this. These are concentric rings formed by this particular fungus. Symptoms also appear on stem and severely infected plants get blighted. Brown discoloration appears on the stem. Dark brown spot with concentric rings up to 1 centimeter in diameter appear on the leaves, which later develop into large lesions. So these actually spots can merge into each other to make larger lesions. Avoid growing in low-lying and flooded areas. So severity of alternaria blight is more when you get waterlogging. Seeds should be collected from disease-free plots for sowing. Seeds should always be treated with a fungicide. Here Thiram, Captan or Bavastine can be used at the rate of 3 gram per kg seed, and it is usually done before sowing. And in the standing crop, spray carbendazim 12% plus mango jab 63%, and overall concentration is 0.2% immediately after disease appearance. So it is a combination of 2 fungicides by a second spray 15 days later. So next important disease of this crop is Cercospora leaf spot, and it is caused by Cercospora carthemi. Plants few weeks after planting or at flowering are attacked. Circular to irregular brown sunken spots of 3 to 10 millimeter diameter formed on leaves. So you can see brown spots on the right side on the leaves. These are very typical symptoms of Cercospora leaf spot. Spores surrounded by yellow halos. So if you see critically outside this brown color, you see some small layer of the yellow color. That is called as yellow halos. First appear on lower leaves and spread to the upper leaves also. Stems and nodes may also be affected. Affected flower buds turn brown and die. Avoid growing in low-lying area and flooding areas. Avoid continuous cropping and follow the crop rotations. And in a standing crop, mango jab can be sprayed at 0.25% immediately after the disease symptoms appear, and it can be repeated at 15 days later also if this disease is not controlled by the first spray. Then powdery mildew, it is caused by Erysipecae cichoracearum, characterized by white powdery growth on leaves. Fungus spreads over entire leaf and leaves turn yellow and dry up. So what can be done to control? Use resistant varieties, follow field sanitation, and spray wettable sulfur 3 gram per liter solution or carbendazim 0.05% for the control of disease. So some fungicides are available that can control this powdery mildew disease. You can see symptoms on the right side on the picture. There is powdery growth of the fungus, white color on the leaf surface. Mosaic, this is caused by cucumber mosaic virus, and plants' young leaves show irregular yellow or light patches alternating with normal green areas. Leaves may become blistered, distorted, and plants are stunted. A few plants' primary leaves are produced, forming a rosette of leaves exhibiting mosaic mottling. That means the internode length is shortened and leaves make a mosaic. Disease is transmitted in semi-persistent manner by Apis gossypi. So therefore, Apis gossypi is the vector that transmits this disease from diseased plant to the healthy plants. The disease can be controlled by roguing and destruction of the infected plants. Spraying the systemic insecticide like acephate 1.5 ml or dimethoate 2 ml per liter of water to control the aphid vectors. Head rot and wilt. It is caused by Sclerotinia sclerotium. Plants become yellowish, turn brown and ultimately die. Large black sclerotia of fungus are formed on the crown, inside the stem, floral heads and adjoining roots. shedding of stem takes place. You can see the symptoms of this disease on the right side picture. Application and incorporation of the beneficial fungus C. miniatans is useful. Spraying azoxystrobin, this is quite useful at the rate of 0.1%, that means 1 gram in 1 liter of water, and make 500 liter of solution and spray to control the disease. The next important disease of safflower is Remularia leaf spot. It is caused by fungus Remularia carthemi. Round and irregular spots of more than 100 millimeter, or you can say 10 centimeter in diameter on both sides of leaf. You can see these yellow kind of spots on the leaf. Whitish dense mass of conidia remain at center which reflect light. Dry spots are brown in color. So what can be done to control Remularia? Avoid growing in low-lying areas and flooding under condition. So in this case, you have seen that most of the fungal diseases occur in this crop due to waterlogging. So in any case, we should try to reduce the waterlogging conditions in this crop. So next important disease of safflower crop is wilt. It is caused by Fusarium oxysporum F species carthemi. So in this disease, what happens? The vascular bundle, particularly the functioning of xylem, is affected adversely, and therefore the transport of water is stopped. So yellowing of leaves on the side of plant starts, particularly from lower leaves, followed by wilting progresses upward. Lesions at soil line in first symptom. Notice which extends inside and affects the vascular system, which is mainly xylem. So you can see the yellowing of lower leaves here on the right side. Plants start to wilt, drooping more often. You can see these leaves, affected leaves will start drooping. Follow crop rotations and avoid water stress. Seed treatment with Pseudomonas fluorescens. So this is a bioagent which can suppress this particular disease. Soil application of Trichoderma Hargenium at the rate of 2.5 kg per hectare. So this quantity of Trichoderma Hargenium can be mixed in some manure, powdered manure, or some soil, and then is spread uniformly in 1 hectare area. Seed treatment with carbendazim or Captan at the rate of 3 gram per kg of seed. So these are the important control measures for wilt of this wilt. Next disease of safflower is root rot. It is caused by Rhizoctonia bataticola. What happens? What are the symptoms? Dark cortical lesions occur slightly below or at soil level on the stem, which later extend upward. So you can see on the right side, this is the lower portion of the stem, and where the infection of the fungus has occurred, and here the rotting starts. Rotting of the stem part starts, and lesions frequently girdle stem. Root development reduced, and finally seedling die. So it can be quite destructive disease at times. Seed treatment with Captan, it is a fungicide at the rate of 3 gram per kg seed, or safflower seed biopriming can be done with Trichoderma Hargenium at the rate of 10 gram per liter water for 12 hours. Now next is rust. It is caused by fungus Puccinia carthemi. Seedling infection cause twisting towards one side. Chestnut brown pustules formed on hypocotyle, leading to collapse of seedling. So this stage is of this disease is of particular importance during the seedling stage or germination stage also. On older plants, girdling and hypertrophy of stem base may occur. Hypertrophy here means just swelling of the stem. And you can see the minor small spots or pustules on the leaf of safflower plant on the right side. Small powdery chestnut brown pustules of 1 to 2 millimeter in size also develop on leaf surface, which later turned black. So you can see change of color is there in this case. Do not delay irrigation until the crop exhibits moisture stress symptoms. Whenever rust is noticed, give 1 or 2 sprays of Calixin. Calixin is a fungicide that can be used at the rate of 0.05%, or dithan 45 can be used at the rate of 0.25% at the fortnightly interval. And also we should take care of the solution. It would require about 500 liter solution per hectare for spraying. Now you have seen the important insect pests and diseases of this crop, and they should be prevented. Prevention is always better than cure, and we should follow the integrated management of insect pests and diseases. And if we follow those kind of practices, surely we will have good crop of safflower. And now how to go for harvesting and threshing of this crop. So all the currently available varieties come to harvest in about 115 to 140 days. This is the duration of this crop in the traditional safflower growing areas. Traditional safflower growing areas are mainly Karnataka, Maharashtra, Odisha. The crop is ready for harvest when the leaves and most of the bracteoles, except a few on last formed flower heads, become dry and brown. The crop should be harvested preferably in the early hours when shattering is minimum and spines are relatively soft. So in some crops where we have shattering habit of the seed, it is advisable to harvest the crop in morning hours when the plants are moist. The plant must be cut with the help of sickles at the base, or wherever possible uprooted. Black soils, it can be uprooted also by pulling and then stacked in the field in the form of a small and well pressed heaps until they are fully dried. So they should be left for few days in the field for proper drying. For easy handling and transport to the threshing yard, sets of plant are arranged in the heap in opposite direction with their cut ends overlapping, and branched and spiny portions are away. This arrangement provides a fairly long and spine-free portion in middle of stacks or bundles. If necessary, improvised sacks and gloves made from used gunny bags may be used to protect legs and hands against spines. So sometimes these spines are there. There may be irritation on the skins. So therefore, person or workers who are handling this crop should get some safety gears. Threshing is done either by beating with sticks or with the help of block-drawn stone rollers are available, or tractor can also be used, and the resulting material is winnowed to clear the seed, because it will have lot of impurities that should be cleaned by the process of winnowing. The threshing and cleaning operation can also be made with power-operated threshers used for other crops such as wheat. So now many modified power threshers are available to thresh the produce, and this will be a clean produce also. Combine harvester used in rice and wheat could also be used for harvesting and threshing. With some alterations, some modification, or with some calibrations, the same threshers or combine harvesters can be used. And as you know, the combine harvester will cut the crop, they will thresh the crop, and they will also clean the crop. In Vidarbha and western Maharashtra, where a sole crop of safflower is grown, the use of combine harvester has become quite popular with the farmers. So combine harvesting area is increasing in the country. Now yield potential. With a full production package, a safflower yield of about 800 to 1200 kg per hectare under scanty moisture or rain-fed condition is obtainable, and 1500 to 2000 kg per hectare under favorable conditions can be obtained. The irrigated crop can yield from 1800 to 2800 kg per hectare with good management. Now post-harvest technology, the safe moisture level of storage of safflower seed is 5 to 8%, and grain bins are quite suited for storage. Oil millers carry out cleaning through manual or power-operated revolving screens. Seeds should be clean and free from all impurities to avoid the poor quality of the oil. And it must be kept in mind that moisture content should not be 5 to 8% in the seed during the storage. If we have say 10%, 12% or more moisture, then seed deterioration can happen by fungi or by some insects or by some abiotic causes also. Dehulling is done prior to the oil extraction. This is done with the help of a decorticator. The decorticated material is sieved and the kernels are separated. Later, the required quantity of water is added and kernels are kept overnight for softening. Seeds are crushed in animal or power-drawn ghanis and mechanical expellers are used for extraction of oil. So, there are number of methods by which oil can be extracted, but for commercial purpose or say domestic purpose, some expellers or machines are available that can be used. There are mainly three methods of oil extraction. For example, immersion method, pressure extraction and solvent extraction. Of course, the recovery of the oil is more from the solvent extraction, but this process is quite complicated. Generally, on large scale, the safflower oil is extracted by different types of ghanis and expellers. These are very common methods to extract the oil. The oil has poor keeping quality and hence the extraction is done as and when the oil is needed. Oil quality in general, safflower seed has 33 to 45% oil and hull and 55 to 65% kernel, 5 to 8% moisture, 28 to 32% oil, 14 to 19% protein, 5 to 7% ash and 30 to 34% crude fiber. Thin hull types contain more oil and protein than the thick hull types. The oil is pale yellow with a bland or slightly nutty flavor. Safflower oil contains 70 to 80% unsaturated fatty acid like linoleic, which makes it good quality oil and sells at premium price. Safflower oil contains 70 to 80% linoleic, 6 to 8% oleic, 2 to 3% stearic and 5 to 8% palmitic acid. Unsaturated fatty acids account for 90% with only 10% as saturated fatty acids. So, you can see characteristics of the safflower cake, and decorticated cake contain 8.7% moisture, and you can see the main point here is that the fat is 10% here and undecorticated fat is 8.3%. Dear students, hope you enjoyed this lecture. Thank you very much.